that affine functions are convex. So I know I can do it like before recording the video, writing this, but I did not do it, so now it's done and I'm doing it now. That's life. Affine functions are convex. So here it is, and so affine function is just defined like this. If you know um, the direct notation, but I think we'll do it without. But just want you to introduce the notation, and so we are not in R like a in school when you were young. You just have this. So you must wonder why we have this, but this is for R. And now we work in R at the power of n, so we work with colons. And so here is the bracket here, that's a notation which is a colon, and here that's something which is a line, like 1, 2, 3, for example, in the matrix, and here 1, 2, 3. So that's for columns and that's for line. And so here, if we want not to use bracket notation, we just can write it like this. And so that's it. So we'll write it like this. This way, because you maybe do not care about learning notation in stuff like this. So yeah. Okay, so we have this, and so how can we do now? As we saw, the thing we want to have is this. To prove it's a convex function, we need to respect this by the definition of convex function that I explained you in the last video, which is called definition of a convex function. So that's it. And after we have this, and I organize the playlist, so you can just go back in the playlist and do not be you don't have to lose yourself. So you have this, and um, okay, how am I supposed to do? I did not prepare this video, so I'll try to sync with you. So we have this, and so yeah, what we wanted to, we have this. No, 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 no. Yeah, so as we see here, x becomes this. So we just have to say that we have this will not change, and that just the x there that will change. So we just have like, so we want this, as we say, so we have this, and so that's equal to, so f of, so here it will become a dagger first. Instead of x, now we have this, so this and this not change, and this, it was this, but now this is this. So we just have to put this inside. Your new x is this, that's your new x in a way. And so up, you just replace the variable, instead of having this, you have this, because this is replaced by this. And so you have this, and now how we can we'll try to arrive to this. But so we just need to expand the a dagger So it's a dagger lambda x plus a dagger y minus lambda y plus b. And so we can try to sum them up, like to factorize maybe, or just using a trick here, like saying, for example, represent b by lambda plus 1 minus lambda. It can be a good trick, like this. Well, that's a trick. I admit, not easy to think about it, but it seems a good things to do here. It's still lambda minus lambda is 0, so you have this. And so after, you can just regrouping the stuff. And so this way we have like trying to factorize by lambda and 1 minus lambda. So you have lambda factor of a dagger x plus b plus 1 minus lambda of a dagger y plus b and so you just have this lambda b here come here and minus 1 lambda b come here, and so we have perfect equality, or we had a dagger x plus b, which is the definition of f of x just here, and so it's lambda f of x plus 1 minus lambda f of y and so we just proved that like it's as we saw, the definition of a convex function is this: it's inferior or equal, but here we only have equality and not different of this. I agree, but that's just a particular case. Like this implies that equality is okay, like 3 inferior of 3, then it's still alright to stay 3 equal 3. So that's just the proof another time. That's a convex function. It's just a particular case. And yeah, that's an affine functions because it's equality, she is concave and convex at the same time. Because if you remember in the definition of convex function and concave function, I told you, like, if you write it like this, it's convex, but if you write it like this, is concave. And so this and this in the same time means equality, and so the function is convex and concave at the same time, and so that's equality. So conclusion: yes, it's a it's a convex function. And yeah, because that's the question. But if you can even say it's also concave at the same time, and we have a particular case, but yeah, it works. And so we just prove our convex function, and that's it for this video. We just finish our proof, and that's down.